Well, here we are. We just scratched the surface in the C13 room. We basically got to the question of how precise do we need to be, but we didn't really get to what range of standards we need yet. I imagine most groups had similar experiences, although I don't know.
There were only 2 groups.
Yeah. Okay.
The groundwater folks joined the radiocarbon groups. But yeah, we just scratched the surface too. But do you want to start?
So I was the rapporteur because everybody's heard enough from me, and then I ended up talking too much anyway. We had some discussions about whether or not it's really reasonable to store seawater DIC samples for isotopic analyses for a very long time. It was agreed that more work is needed on questions of storage, but the way the DIC standards have been used over time, storage hasn't really been an issue. Those groups tend to burn through those. Many in our group expressed a desire, maybe in addition to, but possibly instead of, I don't want to put words in their mouth, a desire for standards in solid state that can be used to create aqueous standards using, maybe we can agree on a standard method for creating that aqueous standard. And we just started talking about really what kind of precision we need for our scientific goals. The big loud ocean C13 guy expressed his opinion, but I think some people maybe got cut off. That's about as far as we got.
Amanda, do you want to?
Yes, I wasn't, okay. So we talked a little bit about the intercomparison. So the 13C people have already done one comparison, and there's definitely a need to do a similar one for 14C. And I think the key part of doing that is identifying who the players are. So we came up with a list, not exhaustive, but an idea of some of the labs, and there's definitely on this range of like 10 so far. So there's definitely a bunch more than what was originally thought, I think. So I think that was a bit surprising. The idea of what vessel to use, maybe we can find some free way of doing, getting water, and then minimal for costs for shipping. Maybe the CRM could be used for both 13C and 14C. We did talk a little bit about what ranges the standards would need to be. 14C ranges from -250 to +50 per mil for groundwater. So maybe we could incorporate 2 standards or something like that, could include saltwater matrix. We talked a little bit about assigning a value to the CRM or to the deep water. I guess this kind of relies on NIST. Please interrupt me if this is not, if I didn't understand completely, but
So
and that
one thing you did get wrong is the -250 to +50 is for seawater.
oh,
The groundwater goes from, I just corrected it there.
thank you.
Groundwater goes from -1,000 to higher.
Wow, that's ginormous. Thanks for that correction. So I guess the thought is to maybe either get a good estimate of the truth or to get everyone on the same scale, and maybe getting on the same scale is more important at the moment, to better figure out the long-term differences, I guess, if we're all on the same scale. There was some talk about proposal writing, and that is it.
The proposal writing was for a radiocarbon comparison experiment. Exercise.
So it would make sense to piggyback a C13 intercomparison exercise on that same effort.
Yeah.
Does
that'd be a
that make
lot more
sense to
people.
you? Well,
Um,
it does include more people, but not necessarily as, yeah.
Yeah, no. But the question was whether there could be a smaller C13. I guess what we really need to do is identify who was left out of the original experiment and exercise. The question was whether you could bring, if it's just a few people, have a smaller exercise that brings them in, but if it is just a few people, you could arrange that with the C14 work as well. I guess I'm starting to fail here.
I've got about 6 labs that I can think of off the top of my head, Weijun, yours being one of them, that was not included in.
Right.
Right.
Excuse me. So maybe if you weren't included in an intercomparison, please put your name in the chat and I'll try to write a list. I mean, some folks have already done that, but if you're if you feel like that would be something that's useful for you, please put it in the chat and I'll try to pay attention.
But there are probably people we don't know about that aren't here. Because I'm sure we didn't
Mystery-
get everyone in
mystery
our
groups.
calls too.
Sure. I mean,
and in an ideal world, this subgroup would somehow relate to your previous intercomparison in some way too, rather than be that there are now 2 sets of data floating around in the world.
Right.
would one do that by assuring that there's some overlap between the 2 groups?
If you're completely confident there are some labs who don't have any change from year to year,
Well, at least the 2 groups are here, right? The Wallace lab and the Paul Queer's lab, these are the 2 in the first comparison, at least.
Right. So yes, there should be overlap. And part of the thinking was that A, radiocarbon hasn't been done before, and B, it's easier to faster to spin up a comparison experiment than to get the reference material around to the labs, certified and around to the labs. So if I'm wrong in that assumption, please tell me. So anyway.
So Anne, if I can jump in here, I think your assumption is right there. I will go back to something that Regina, though, presented in her talk, which is the idea of what we've started calling an RGTM at NIST, a research grade test material.
Mm-hmm.
In other words, what I'm saying is that maybe there should be a little bit of discussion about whether such an interlaboratory study could actually be part of producing a reference material for the first time with with NIST involvement. You may find some bugs in the system by doing that.
Yes, I actually forgot about that. I liked the concept of a research grade test material, even if it is a little tough to trip up.
It's kind of a poor man's RM in a way, because it's not really a full reference material, but
right.
But we're using it as a way to test candidate reference materials to see whether they really fit the bill. So
yeah, no, it's a step on the way.
Yeah.
Phew, lots to think about.
Sounds like for either of these, C14, C13, both, for an intercomparison, I guess, I mean, we need number of labs. Effectively, we need how much material are we talking about? I think that would drive how we source the material and the funding of it, right? I mean, if it's small scale. So it's obviously related to the number of labs that are interested in participating, but we really that's where we need to narrow down what volume of water are we talking about?
Two people I would have liked to chime in on this are the West Coast people So, but Zhang Zhu is not here, and neither of the walkers are here. So they would know how.
Bob Key's hand is turned orange and he's got it up.
Just very quickly, I was going to say, when we start talking about CRM for either isotope, we have got to go from day one with the carbon community, because they're 10 times, well, at least 5 times bigger than we are in terms of usage. And failure to coordinate with with the AOML and PMEL labs in the US and the JAMSTEC in Japan and so forth would be a major mistake, I think. Because I think Ann's right. I think we can, at least the odds are high that we would be able to piggyback on top of their large needs without a lot of difficulty. That's it.
Andrew's hand is up.
Yeah,
Andrew
my
Dixon.
comment is about the container you put the liquid in to ship it around. Obviously, the bigger it is, the heavier it is, the more the shipping expenses are, the more water you need. The current in my lab of 500 mils was a very early decision that the 1 liter that Keeling loved was totally unusable. And most people felt they could work with 500. As the years have gone by, I think a proportion feel they might be able to work with 250. The problem is this, that you have a bottle that you are looking to transfer water out of without any gas exchange for the total carbon measurement in a quantifiable fashion. And traditionally, the approach has been, if you pressurize it from the top and take the water from the bottom, the effect of gas exchange at the top probably hasn't compromised the bottom by the time you stop taking water out. And for 40 mils, that's certainly true. And we have on occasion taken 80 mils, that is 2 40 mil pipettes in series, with very rarely a suggestion that it has changed. But there is experience that if there's time between taking that first part and the second part, they do change. And so this is my comment about the flexible packaging that Wei Jun shows has many advantages from that point of view, but that's a whole new development concept. But if you're distributing to go around, part of it is getting the water, shipping the water, but the people at the other end not being able to blame the fact that they didn't have enough water for the fact that they don't like their results.
So, Rafa, am I correct that Paul Quay has been using 250 milliliter bottles for a very long time?
Yeah. Mhm.
Yeah.
That's what I saw. I saw 250 ml bottles everywhere in that lab. This is an amusing anecdote that we don't really need to discuss at all, but he also had a box on his lab counter that just said instant ocean, just add water. And that is one of their working standards, is they just stir up a big vat of that stuff and use that as one of their, as a check on their extraction system. They bought it at an aquarium shop. It's very similar to Wei Jun's use of baking soda from the grocery store.
Yeah, for years, we just used Andrew's CRM as kind of standard, but because our analysis use small volume, like for DIC, 1 to 3 milliliter. So very soon that bottle of 500 milliliter gets wasted, right? Halfway, it's already too long. So then, since the pandemic started, we couldn't buy as many, even if we wanted to. So that forced us to calibrate our own bag at the standard, use CRM. So I make sure I use CRM from 2 different batch at least for this bag. And yeah. And then I use the bag as internal secondary standard.
And there's been some experience using those bags, and if they're used over multiple weeks, it's not clear that there is no drift.
So Fred Sales, my postdoc advisor at Woods Hole, he used that for his Lander analysis, he actually added 3 times of mercury chloric acid, that poisoning added to your CRM. Actually, he got a CRM from you, open that and add more. And then he put it at for months.
I happen to be married to Fred Sales' collaborator, Bill Martin, and he has nothing good to say about those bags. My husband, Bill. I think there's a lot of variable experience with those bags. So
yeah, I agree. We had some, but for the few one we are using, for that, at least for the cruise, so it seems it's quite a stable.
Wei Jun, you're not talking about freezing them though, right? You are putting.
No, not freezing. We just
Yeah.
add mercury chloride to the bag, aged seawater, I call it. Yeah. Or actually, I use sodium bicarbonate, so there is less, bacteria growing compared with seawater itself.
So, yeah, there's many possibilities for sample bottles and stuff, but it seems for an initial comparison experiment, the way to go would be with a tried and true method. And if you want to put some other things in, oh, I see, Andrew. I wouldn't change something right at the beginning when you're trying to establish that everybody's measuring the same thing.
Yeah, the comment I just wanted to make is that there are countries for which it's getting harder and harder to ship samples that contain mercuric chloride. And so if those are collaborators that you wish to have in your group, this creates a potential problem. Japan, there is an official way around it. The Nordic countries, largely only if they do it under the table is the impression I get. But I don't know that for a fact. That's a personal opinion.
Well, the other thing, Andrew, that's different for this group than the carbon group is the cost per analysis. For this group, it's about an order of magnitude higher than it is for the carbon group. And consequently, and I'm not saying it doesn't solve a problem for you to go to, say, a 250 mil sample, but the shipping costs are noise level. When your analysis is $500 per number, those costs just don't count.
That's certainly true if the people making the analyses think about budgets in that way.
Yes.
Only a limited subset of scientists, in my experience, do. And so, if this is the group sending them out, paying for the sending, then it matters. If it's really seen as the total cost of the exercise, you're exactly right.
Well, and
Without
even these,
doubt.
sorry to cut you off. I mean, even these days, Bob, those are separate. Those are paid totally separately for GoShip, for example. I mean, that's the sampling analysis cost is separate from the shipping costs. Those are different pots of money entirely.
Yeah, that's a very unusual pay arrangement that NOSAMS has for those, though. But you're right. Yeah, at NOSAMS they are separate, but for most places they would be lumped together.
I don't know how to put my hand up. Bob, how many CRMs does a DIC group use on a cruise?
They typically use 2 per day.
So 60
is well, on 60-day cruises, so 120 of them. Does that sound about right, Andrew, or is it more than that? Say, how many did Wanenkoff order for A13.5?
On a happy day, they will try to order 200 or 300 for use on the cruise.
Yeah.
Because usually they have 2 instruments running.
Right.
And yeah, they are using them 2 a day, but every time they're setting up an instrument or checking a calibration or whatever, they use more.
Yeah.
They're shared because they are 500 ml bottles and they only used a small amount.
Right.
The leftovers get used by my group when we're on the cruise as alkalinity reference materials, which makes for some saving. And that's one of the benefits of the larger bottle, is that for that purpose, it's practical to get both analyses out of the same bottle.
Yes,
But-
that's right.
The reality is they do use a lot by preference. I mean, we've had to beat people down saying, sorry, you're only getting 40% of what you wanted.
Yeah, well, and it's
So
worse
it's
if
got
you,
tougher.
yeah, if you bring the samples back to the lab, then it gets much worse because you're not running 24/7. So you've got to calibrate. The number of calibrations per sample goes way up if you're running on shore.
But that means of your each batch, they're heavy users then. I mean, the Go Ship program is really taking a significant portion, or?
Yeah, I would say of the total that we distribute, the Go Ship open ocean usage, let's put it that way, which isn't just Go Ship. There are some countries that do those kind of measurements. For instance, the NOAA West Coast cruise and their GOMET cruise that you heard about earlier, although run pretty well like Go Ship cruises, aren't originally normally classified as that. But those large, more oceanic cruises, probably, I would guess, if I went back and looked, use about a third of our total number of reference materials. But they are perhaps 5% of our total number of shipments of reference materials.
Oh, yeah. All right.
Yeah, and hopefully you ship a fair number out to the few European countries that participate in Go Ship, and
Yeah,
and certainly to Japan as well for
the big users
Jamstick
are the US, Germany, and then followed at some distance by Japan and Australia.
Yeah.
And then the UK's kind of comes in a little bit there too. But
and is that just Brawny down in Australia?
yes. I mean, in terms of the large cruises, yes.
Right.
We have many other people we distribute to in Australia.
I guess I was just thinking how we would scale that, for the isotope community. Would we expect that NOSAMs or the people making the Go Ship measurements to also be a third of the user of the volume of reference material? Or do we expect that proportion to look a little bit differently for this community? Just
Yeah, I think you'd get a clearer, what I'm hearing listening to you is there's two classes of people. The people that do so much, they do it all in their own lab. And the people that do sufficiently less, having those groups that actually run service measurement laboratories on a broader community's behalf are involved. And I think you need to think about both of those audiences, although the simplistic large number oceanic audience is probably the first.
It's not as simple as you think.
Sadly.
Less complicated. Roberta, I was going to ask you point blank how many CRMs you would use in a day, but I'll just say that at UW, we run our working standard several times a day, but it doesn't necessarily need to be a bottle from Scripps. We can use a CRM less frequently and then use our sort of in-house working standard more frequently. I think the DIC group, because they can afford it, and they tend to use quite a few CRMs, but we have working standards that we can relate to the CRM during the day. So I guess the question is, maybe you and I ought to put our heads together and figure out just how many we need for a Go Ship cruise.
Well, I can give you, Kathy and I were talking about this sort of offline. If we wanted to just insert it as a working standard, 200 to 300 a year is what she estimated we would use. But we also, as you mentioned, could arrange our model a bit differently and use it, use it more sparingly and use it as a check towards our own already existing internal standards. So we could be either end of that range, or, that would be a maximum on down.
And if you were to consult with, measurement statisticians, you would recognize that one of those probably is better than the other. The question is whether it's enough better to justify the added trouble and expense.
Yeah, that makes sense. We were just talking, just we were to insert it in the place of some of our existing internal standards. That's what the numbers would look like as a maximum. But you're right. I think it probably wouldn't make sense to run it that frequently. We'd have to do that analysis.
And until shipboard measurements of radiocarbon happen, there won't be any need for the radiocarbon program to put reference materials on the vessels. So, and I think we're a little bit of a ways off from, actually, I don't think we're as far off from extracting the samples at sea, but definitely from measurements.
Well, certainly if you extracted, you'd want to extract some CRMs out there.
Yes, absolutely. Absolutely.
And well, you're talking about a cost benefit, or Andrew was talking about a cost benefit analysis, and I don't know. We could make a stab at that. I'm not. We would be making so many assumptions right now that the value would certainly be limited, but it might be a useful exercise to even this early do a cost benefit, so that if nothing else, we could inform NIST and or Andrew about what sort of number, say if you were going to run 1,000, collect 1,000 samples at sea, how many CRM would be needed under scenario A, B, and C, or if there were that many.
Yeah, my comment was merely meant to convey the fact that those cost benefit analyses are done implicitly by every choice you made. You probably didn't actually just do the arithmetic.
That's right. Yeah, and then having looked at an awful lot of numbers, I can tell you bad ones are expensive. They're very, very expensive.
Well, guys, this is really quiet, so I'll waste a little bit of your time. It seems to me, coming from the outside, we already have a producer of a water standard. So that box can be ticked. It needs a bit of work, but it's there. What we don't have is a range and C13 standards. I would strongly advise to include all the DIC users, not just sea water people, and think about this issue at large, in a sense that the world of DIC, in fact, includes a range from +5 to -20 per mil. That's what we have out there in nature. I think if this group was to ignore that, it'd be really limiting itself to a very small bubble. That being said, the wider range DIC people don't require this 0.03 per mil uncertainty. We can live with 0.1 easily. Hence is the possibility to use the powders, I think then become viable, possible, easier. And of course, one approach does not exclude the other one. So in a perfect world, one could have 4 DIC powders, one at +5, one at 0, one at -2. So then that really brackets your range. And then one at -20. Everybody is happy. I would use probably all 4 standards. You could only use 2 because you don't need this extra range. And to make sure that everything is good, you use the water standard to as a check. It seems to me an approach like that would include everybody and would answer, would tick most boxes. It's not perfect, but it would be a start. And in a perfect world, one of those powders would be dead, one of those powders would be half dead, and one of those powder would be modern. So then we please the C14 people also. And if you want to please me, you mixing a DOC standard with that DIC, and hey, and then I'm really happy. But then I'm masking it maybe a bit much, right?
Well, we all have our dreams, don't we? We'll definitely take your comments seriously and in consideration. It's time for us to start wrapping up. People are on very different time zones, and so I wanted to thank everybody who presented and everyone who contributed. Just by being here, we've all learned a lot. I think the immediate thing I see going forward is that there will be a proposal for a C13 to C14 seawater comparison experiment. To start this, we need to solicit who is making these measurements. Just as I said, and I would love people to put in the chat or email later or add it to one of the documents. Where are venues to ask people if they're making these measurements? There's the OCB can do it for me, can help us. There's the IsoGeochem mailing list, the radiocarbon mailing list. Those are 3 that come to the top of my head, but
IOCCP, the International Ocean Carbon Coordination Project.
Right.
Program.
Yep. Okay. I actually am not on IsoGeochem, but I'll find somebody who is.
Is it practical to contact the companies that are currently distributing appropriate solid reference materials and ask whether they could distribute it or if they would help to distribute such a suggestion? Or are you only looking at the aqueous measurement fraternity sorority?
For this initial thing, that's where I think I'm going. But if we follow up on what Paul is suggesting, that's probably a good idea. So and as we go through this comparison experiment, the idea of reference material and actually making it a reality will be addressed in concert with the comparison experiment and in conversations with NIST as well as whoever else is appropriate, including Andrew. I think this comparison experiment will want to use some of your seawater. So,
yeah, one aspect I would point out, and I'm sure the people from NIST could be more clear about this, is if you're imagining a consensus value from the measurements you make on such a reference material, talking with their statistical people to discover how you best plan such an experiment in terms of quantities of stuff sent out, replicates made, would be a very useful piece to think about. Whether that's necessarily your level 0 test of naught. But I think by the time you're going to level 1 or 2, you really want to bring that in.
Yes, Mike Winchester had some suggestions, or basically stated
Yeah.
that he had some ideas about that.
Yeah, I mean, I'll second what Andrew said. Probably one of the biggest complaints of our statistical engineering department is that sometimes we forget to advise, to consult with them before we design an experiment. So it makes things a lot easier if you start with them on the front end.
Yep.
You know, I worked with Lloyd Curry, who used chemometrics all the time. So, but so he's ingrained that in me as well. So.
Yeah. So, I mean, you already said that, you know, do remember to include us in the conversation. And I was having a separate chat with Elizabeth during this, and if a proposal is written, it is possible for NIST to act as a subcontractor for a PI. So that would help grease the skids from our end, if it makes sense for us to be a part of it.
Okay. That's why we invite you guys here. Does anybody have any final things? I think, as I said before, thank you all for your participation. I wish I could give swag to everybody, but and this is not done. So please send comments that you have, observations, whatever. I will be trying to, with my co-conveners, organize what happened here and get a letter out to the OCB group. And if we're really ambitious, we'll put one in EOS, but I'm thinking about NSF proposals. If chemical oceanography is the place to go, their next deadline is February 15th. Am I correct? So.
Yep, that's right, Anne. And you know, we would be welcome. We would be happy to talk with whoever is going to be part of the proposal writing team.
Okay. Sounds good. So
I guess maybe I missed something. It sounds like we're talking about proposing a C13/C14, mostly C14 motivated, but including C13 intercomparison experiment and pursuing use of CRMs as part of that experiment, sort of folded in.
well, I haven't thought this through, so I'm not going to commit to anything right now. So.
Okay, I was just wondering if because there are broader needs, and if we should be pursuing sort of parallel efforts or an all-encompassing effort. Just put that out there.
Yeah, no, it's. I tend to like to be focused and
Right.
and not because.
Those proposals review better. Focused proposals review much
I
better.
was just going to say I've gotten killed on getting too broad and leaving.
So maybe we're talking about two, possibly three proposals that share similar goals, but are addressing different questions.
Yes, I think that would.
And conceivably that build on one another.
Right.
Hopefully.
One last question for Andrew. We had attempted to tie into the carbon community via Dennis Perot, and he couldn't make it. So that's why Rick was in on a few of these. But do you have other suggestions so that we can stay coordinated with the carbon group? I mean, you must be aware of what they're doing.
The open ocean carbon people, probably your best contact group would be the IOCCP that Heather mentioned earlier.
Okay.
But there is a wider group than just them, and going beyond that, possibly, my mailing list, for want of a better phrase, of people at least gets, if you really want to go widely in the marine science community and CO2, then we have that. But they're not isotope, of course.
Right.
Well, they may be isotope, but very few of them likely even confess that to me.
Okay. Shall we spin the wheel?
I want to say thanks to Anne for putting this together. I mean, Bob and Roberta and I are co-conveners and all that, but Anne really did a lot of heavy lifting here. And thank you, Anne.
Absolutely.
Thank you, Ralph. Thank you.
Thunderous applause.
Okay.
Look at that.
Hey,
You're doomed, Jeff.
Yeah.
You are a winner.
Still here?
Not
Yeah.
sure that he is.
Oh,
He's
he's
not
not
here.
here.
He's not here. Oh, no. Right,
It was close
did
enough.
again.
Quick, run, folks.
Whoa.
Last chance.
No, 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 no.
Oh.
That's not right.
hey.
Well, you deserve it.
The winner we've all been hoping for.
Oh, well, thank you, but well, everyone will be hearing from us in the near future. So I
Thank
think you
you.
know my address. So everyone have a nice evening, nice afternoon, nice lunch, whatever. And
Thank you.
All three of
Bye-bye.
those,
Right.
ideally. Thank you.
Okay.
yes.
Thanks a lot.
Thank you.
Thank
Thank
you. all.
you.
Ann.
This has been
All
great.
right.
Who was that?